Hi, this is first of several videos on radioactive reactions. The first thing that I want to do is just go over a couple of things that are applicable to all reactions. First of all, there's a thing called conservation of mass. Remember this top number? This is protons plus neutrons. On the reactant side, I have one proton plus neutron here, two here, so I must conserve those. Those two added together must equal this number. Also, helium, you can look at this bottom number. You can find this on the periodic table. It's the top number on the periodic table. So for hydrogen, it's going to be 1. Because I have 2 protons on the reactant side of the reaction, I'm going to have 2 protons on the product side. This reaction here is an example of our one of our first categories. Our first category is fission and fusion. Fission means to break apart. Fusion, like the word fuse, means to put together. If I look at the reaction that's down there, what you're going to find is that I'm going to try to identify atoms. I have 2 atoms on this side in my reactants and only 1 atom in my product. As a result, I'm putting things together. This reaction is fusion. The next reaction here, if you'll notice, if you look on the reactant side, this right here is not an atom. If you'll notice, it's not a capital letter. We know it's not a proton because the 0 shows up here. But this shows up where there's a proton and a neutron. That thing is a neutron. That's how it gets this type of reaction going. So on the reactant side, I have 1 reactant. And if you look over here, I have 2 products plus some more neutrons. This just means I have 3 neutrons. Okay? This reaction, I take 1 big atom and I break it into 2. This is called fission. One way to really identify fission and fusion is that you'll notice you'll always have a plus sign on the reactant side. You've got to do something to fission and fusion in order to have them happen. Contrast that with the next 3, alpha, beta, and gamma, which only have 1 atom on the reactant side.